Right now, as you watch this, you are orbiting a monster. Every star you have ever seen, every constellation ever named, every planet ever discovered, all of it circles a single point of absolute darkness at the center of our galaxy. An object 4 million times the mass of our Sun, compressed into a region smaller than the orbit of Mercury. We cannot see it. No one ever will, because this object does not reflect light, does not emit light, and does not release anything that falls into it. It is a supermassive black hole, and it is not alone. Astronomers now believe that nearly every large galaxy in the universe carries one of these monsters at its core. Some are millions of times the mass of the Sun. Others are billions. And at the very edge of what physics allows, there are giants so large that our entire solar system could fall inside them and never touch the walls. In the next 30 minutes, we're going to travel from the black hole hiding in our own galactic backyard to the largest single objects ever measured in the universe. And along the way, we'll confront a mystery that keeps astrophysicists awake at night. These monsters should not exist. Not this big, not this early, and yet, there they are. Forget everything science fiction has told you. A black hole is not a hole, not a tunnel, and not a cosmic vacuum cleaner. It is the simplest and most extreme object in the universe, a region of space where so much mass has been concentrated that space itself collapses inward permanently. Every object in the universe has an escape velocity, the speed you need to break free from its gravity. On Earth, it's about 11 kilometers per second. On the Sun, over 600. But if you compress enough mass into a small enough space, the escape velocity exceeds the speed of light. And since nothing in the universe can travel faster than light, nothing, no rocket, no signal, no information of any kind, can ever leave. The boundary where this happens has a name: the event horizon. It is not a surface. It is not a wall. It is simply the line in space beyond which the universe loses all contact with whatever crosses it. Fall through the event horizon, and as far as the rest of reality is concerned, you have ceased to exist. And here is the detail that changes everything. Black holes have no size limit. A star can only grow so large before it tears itself apart. A planet, a galaxy, everything in nature has a ceiling. But a black hole can grow forever. Feed it, and it gets bigger. Merge it with another, and it gets bigger still. Given enough matter and enough time, there is no maximum. Hold on to that thought, because it's about to become very important. Point a telescope toward the constellation Sagittarius in the direction of the densest, brightest region of the Milky Way. And you are looking straight at the heart of our galaxy, 26,000 light-years away. Hidden behind curtains of interstellar dust, at the exact gravitational center of everything we call home, sits Sagittarius A star. For decades, it was only a suspicion. Then astronomers began tracking the stars closest to the galactic center, and what they saw defied belief. Stars whipping around an invisible point at up to 24 million kilometers per hour. One of them, a star called S2, completes its entire orbit in just 16 years, plunging so close to the unseen mass that its light visibly stretches under the strain of gravity. From these orbits, the mathematics allowed only one conclusion. Something with the mass of 4.3 million suns is packed into a region smaller than our solar system, and it emits almost no light at all. Nothing in physics can be that massive, that small, and that dark. Nothing except a supermassive black hole. The astronomers who proved it, Reinhard Genzel and Andrea Ghez, received the Nobel Prize in 2020. And in 2022, the Event Horizon Telescope finally captured its image, a glowing golden ring of superheated gas surrounding a circle of perfect darkness. The monster at the center of our galaxy has a face, and every single one of us lives in its orbit. Here is where the story stops making sense. A black hole grows by feeding, but feeding is slow. As matter spirals inward, it heats up and radiates energy, and that radiation pushes back against everything else trying to fall in. This creates a natural speed limit on how fast a black hole can grow, known as the Eddington limit. Run the numbers, and a black hole born from a dying star, even one growing at the maximum possible rate without ever pausing, should need billions of years to reach 1 billion solar masses. And yet, when astronomers point their telescopes at the most distant reaches of the universe, they find quasars powered by billion solar mass black holes that existed less than 700 million years after the Big Bang. That is the paradox. We observe monsters that did not have time to grow. It's like finding a fully grown blue whale in a pond that was dug last week. The math doesn't work, which means something in our story of the universe is missing. Scientists have proposed radical solutions. Perhaps the first black holes didn't come from stars at all, but from entire clouds of primordial gas, collapsing directly into black holes tens of thousands of times the mass of the Sun. Born big. Perhaps some are primordial black holes, formed in the first second of the universe itself. The James Webb Space Telescope is now finding more of these impossible giants than anyone predicted. And each new discovery makes the mystery deeper. Whatever the answer turns out to be, it will rewrite a chapter of cosmic history. For a century, black holes existed only in equations. Einstein's general relativity predicted them in 1915, and Einstein himself doubted they were real. How do you photograph an object that, by definition, emits no light? The answer: you don't photograph the black hole. You photograph its shadow. As matter spirals toward the event horizon, it accelerates to nearly the speed of light and heats to billions of degrees, glowing brighter than entire galaxies. Against that blazing backdrop, the black hole itself casts a silhouette, a dark circle where light bends so severely that it either falls in or wraps around into orbit. To resolve that shadow from Earth, you would need a telescope the size of the planet. So astronomers built one. The Event Horizon Telescope linked radio dishes on 4 continents, from Hawaii to Spain to the South Pole, into a single virtual instrument with the sharpest vision in scientific history. Sharp enough to read a newspaper in New York from a cafe in Paris. In April 2019, the world saw the result. A glowing orange ring surrounding perfect darkness, the supermassive black hole of galaxy M87, 6.5 billion times the mass of the Sun. It was the first direct image of an event horizon in history. A photograph of the edge of reality itself. 3 years later, the same team unveiled Sagittarius A star, our own monster. The age of black hole astronomy had begun. In 1963, astronomers found something that shouldn't exist. Points of light that looked like faint stars but were burning from billions of light years away. To be visible at that distance, each one had to outshine an entire galaxy of 100 billion stars, from a region smaller than our solar system. They called them Quasars. For years, nothing in known physics could explain them. The answer, when it came, was almost frightening in its elegance. A quasar is a supermassive black hole at dinner. As gas, dust, and shredded stars spiral toward the event horizon, they form a whirlpool called an accretion disk, matter, orbiting at half the speed of light, compressed and heated to hundreds of millions of degrees. This process is the most efficient energy engine in the universe. Nuclear fusion, the power source of stars, converts less than 1% of matter into energy. An accreting black hole converts up to 40 times more. A single feeding supermassive black hole can outshine every star in its galaxy combined, powered by pure gravity. And here's the twist. Quasars are not exotic, distant curiosities. They are a phase. Nearly every large galaxy, including our own, was likely a quasar once, blazing across the universe while its central black hole devoured everything within reach. The monsters we see sleeping today were once the brightest objects in existence. Ours simply finished eating. Somewhere in the constellation Canis Venatici, 10.8 billion light-years from Earth, shines a point of light first catalogued in 1957 as a faint blue star. Its name is TON 618. It is not a star. It is the light of an accretion disk surrounding what may be the most massive black hole ever measured. The numbers stop feeling like numbers at this scale. TON 618 is estimated at somewhere between 40 and 66 billion solar masses, more massive than every star in the Milky Way combined. Its event horizon would swallow our entire solar system dozens of times over. Light itself, the fastest thing in existence, would need days just to cross it. And TON 618 shines. The quasar it powers radiates the light of 140 trillion suns, making it thousands of times brighter than our entire galaxy from a single object. When the light we now see left TON 618, the Earth did not exist. The Sun had not yet been born. The universe was barely a quarter of its current age, and this monster was already fully grown. Astronomers had to invent a new word for objects like this: ultramassive. And TON 618 may not even be the largest. A black hole in the Phoenix cluster may exceed it. In 2025, gravitational lensing revealed a 36 billion solar mass giant hiding in a galaxy called the Cosmic Horseshoe. The record books are still being written, and every year, the ceiling gets higher. For decades, astronomers assumed supermassive black holes were passengers. Massive, yes, but irrelevant to the galaxies around them. After all, even a monster like Sagittarius A star makes up less than 1% of the Milky Way's mass. Then they discovered something strange. The mass of a galaxy's central black hole is tightly linked to the behavior of stars tens of thousands of light years away, far beyond its gravitational reach. Somehow, the black hole and its galaxy grow together, in lockstep, like they are communicating. The mechanism is now becoming clear. When a supermassive black hole feeds, it doesn't just consume, it erupts. Jets of particles accelerated to near light speed blast outward for hundreds of thousands of light years. Winds of radiation sweep through the galaxy, heating gas clouds and shutting down star formation across entire regions. This is called feedback, and it makes supermassive black holes the thermostats of their galaxies. Too much feeding, and the black hole blasts away the gas that forms new stars, freezing its galaxy's growth. The galaxy and its monster regulate each other across cosmic time, locked in a relationship that shapes everything. How many stars form, where they form, and when a galaxy stops growing altogether. Which leads to a quietly staggering conclusion. The galaxy you live in, its spiral arms, its hundreds of billions of stars, the quiet stellar suburb where our sun was born and life became possible, may have been sculpted, in part, by the monster at its center. The black hole is not a passenger. It is an architect. So let's return to where we began. Tonight, when darkness falls, look toward the constellation Sagittarius. Behind that veil of stars, 26,000 light-years away, the monster at the heart of our galaxy is turning, and you and everything you have ever known are slowly orbiting it, completing one full circle every 230 million years. There was a time when we imagined black holes as destroyers, cosmic horrors devouring everything they touch. The truth science has uncovered is stranger and far more beautiful. These monsters built the great structures of the cosmos. They regulated the birth of stars. They shaped the galaxies, including the one that shaped us. We live in a universe of monsters, and it may be precisely because of them that we are here at all. Small, curious creatures on a quiet blue world, looking into the darkness and finally beginning to understand it.